Good morning, math friends. It's Mrs. Santa Rosa here to teach you lesson day 4 of Unit 3 because I can't be with you today, unfortunately. But I'll be back on Monday. So, in terms of the substitute should have given you a piece of what I like to call Krabby Patty paper, but it's just really patty paper. And I want everyone to have one piece of Krabby Patty paper and also a protractor. So if you need to get a protractor or a piece of patty paper, please do so now. Okay, so once you have your piece of Krabby Patty paper, let's follow the directions on the opening exercise, which is here. So on your piece of Krabby Patty paper, please draw a line segment and label it AB. Any line segment you choose, whatever you want, you're going to label it AB. So here's my line segment. And this is A. That'll be B. Okay. Second, part B. It says create a 30-degree angle at point A with the protractor. So I'm going to bring my protractor over to A. And remember that we want to put the center of the protractor on A. And I'm going to create a 30-degree angle using my protractor. There we go. 30-degree angle would be approximately there. And then what I'm going to do is, with my ruler, and you are too with your ruler, you're going to draw a line. So here's my line. And, make it longer than what you think is necessary. Pass the protractor. All right, part C. Now we have to create a 50-degree angle at point B with the protractor. So I'm going to move my protractor over to B. So the center of my protractor is now over B. And I'm going to create a 50-degree angle. Now remember, we're coming from this side. So here's 0, 10, 20, 30, 40, and 50. And I'm going to draw a line. And there's my triangle. Now I can remove that protractor and we can take a look at our triangle. All right, so I want you to take a moment, actually pause this video for a minute, and with your neighborhood, your buddies, your partners next to you, I want you to compare your triangle with other students around you. And I want you to see if your triangle, and we'll call this C up here so that we have triangle ABC, if your triangle ABC is congruent to other people's triangles ABC. So go ahead and stop this video, pause it, take maybe 30, 60 seconds to turn and talk and see. Okay, so hopefully you turned and talked and you discovered that your triangles were different from one another, that they were a different size, but same shape, just different size. So in question number 1, does knowing two angle measures guarantee that the triangles were congruent? Does knowing that we had a 30-degree and a 50-degree angle to construct make these triangles congruent? Does it guarantee them? And of course the answer to that would be no. No, absolutely not. Knowing two angle measures does not guarantee the triangles are congruent. So here's the million-dollar question. What other pertinent information did you need in this exercise to be able to create the congruent triangles? What did I leave out? What didn't I not give you in the directions? And if you thought about it for a second, the first step I told you was on a piece of Krabby Patty paper, draw a line segment, label it AB. I never told you what size line segment to draw. So the other pertinent information we need is the length of AB. If we had been told to draw a 2-inch segment of AB, then we all would have had congruent triangles. So we have just established that knowing two angle measures and an included side, that means the side is between the two angles, included side will prove two triangles are congruent. We have also just shown that two congruent angles alone does not prove triangles are congruent. It is not enough. So that leads us to another congruence criteria called angle, side, angle. And of course we abbreviate that with ASA. So in my picture, if you are given two triangles, ABC and A prime, B prime, C prime, which looks to me, in terms of the rigid motion, looks like we have a line of reflection coming through AA prime and CC prime here. Also, the orientation has been reversed. This definitely looks like a reflection. So based on the fact that we have a rigid motion, which is the reflection over this invisible line of reflection here, we know that these triangles are congruent. But that being said, if we also know that the measure of angle CAB is congruent to the measure of angle C prime, A prime, B prime, which I have single arced, and if we know that AB is equal or congruent to A prime, B prime, which I have single marked, and if we know the measure of CBA, which is double arced, is equal to the measure of C prime, B prime, A prime, which is also double arced, then the triangles are congruent. Now it is important that the equal side, equal or congruent side, must be included in between the two angles. So it must be included between the two congruent angles. Okay? All right. And of course, if you have questions about this, you come and see me on Monday. Flip your page, go to the other side. Let's take a look at exercise 1. And let's see what we have. Given M is the midpoint of HP, and the fact that the measure of angle H is equal to the measure of angle P, we need to prove two things. One, that triangle GHM is congruent to triangle RPM, and HG is congruent to PR. So if M is the midpoint of HP, well, what does that tell us? Well, if M is the midpoint of HP, then what that means is HM is congruent to PM. Also, they give us the measure of angle H is equal to the measure of angle P. And we need to prove the triangles. Well, remember, to prove the triangles congruent, we need a third congruency. So far I have two, which I will state in my proof, but if you look at this picture, we can see that the vertical angles, sorry about that, my email was open. If you look at the picture, you can see that it has vertical angles. So the vertical angles, of course, are also going to be congruent to each other. And there's our third congruency. So if you look at this particular markings, this is why it's so important to mark your pictures, you now have an angle, side, angle. And the side is included between the two angles. So let's formalize the proof. So step 1 is to restate our given. So M is the midpoint of HP, and the measure of angle H is equal to the measure of angle P. That, of course, is given. I'm going to go ahead and get those segments. HM is equal to PM, or we could also say congruent if we were to put segment bars of the congruency. And the reason is because the midpoint forms two equal segments. And then I'm going to get the vertical angles, which I'm going to label this angle 1 and 2 for quick reference. So the measure of angle 1 is equal to the measure of angle 2, and that's because they're vertical angles, and vertical angles are equal. And again, don't forget, in the given, they gave us the angle H and P. So there's our 1, 2, 3 congruencies. So we can go right ahead and say in step 4 that triangle GHM is congruent to triangle RPM, and that is because of our new angle side angle congruence criteria. But there is another step, and that is, can you prove now the corresponding parts, which I'll change color, HG and PR are now congruent? And the answer is yes, yes we can, because if the triangles are congruent, then all corresponding parts of those congruent triangles are congruent. So I'm going to finish up my proof with saying HG is congruent to PR, and that is because of corresponding parts of congruent triangles are congruent, also known as CPCTC. Okay, so let's take a look at exercise 2 now. In exercise 2, we are told that angle BAC is congruent to DCE, so we'll mark them. We're also told that AC is congruent to CE, so we mark it. And then we're told that BC is parallel, so we'll mark that with arrowheads, is parallel to DE, which, remember, when we have parallel lines, gives us all kinds of angle relationships. And if we're looking at proving these two triangles congruent, I already have an angle side. So if I can get this other angle here, which I believe I can, because these two angles happen to be corresponding angles. And what do we know about corresponding angles when the lines are parallel? They're equal, exactly. So in step 1, they've restated the given for us, which is convenient. And in step 2, we begin our proof. And I'm going to start with those corresponding angles. So angle BCA is congruent to angle DEC. And here's why. If lines are parallel, which they are, corresponding angles are congruent. Okay, now in step 3, let's look at what we have. They stated a congruency here in the given. They stated the side congruency here in the given. That was 1, that was 2 congruencies, and I just got my third with the corresponding angles. We're done, folks. Triangle ABC is congruent to triangle CDE. And the reason is by angle side angle congruence criteria. All right, turn page, and I think that's it. I think we're done. Okay, so no, we're not done. Here we have the next page in our notebook file here. Another congruence criteria, which is called side-side-side triangle congruence criteria. Okay, so given two triangles, ABC and A prime, B prime, C prime, which looks like, if you think about the rigid motion here, it looks like A went to A prime, B went to B prime, and C went to C prime in parallel and equal vectors, translation vectors. So definitely a rigid motion. We know this triangle is congruent to that triangle. But if AB is equal to A prime, B prime, and BC is equal to B prime, C prime, and AC is equal to A prime, C prime, then the triangles are congruent. So that's a nice easy one, side, side, side. So let's look at example number 3. And these do overlap. So you have to be really careful about the overlap. So I'm going to outline this one in purple, and then maybe this one in green. And there's the two triangles. Notice that they overlap on the base here. Okay? So what they tell us is that AB, which is this entire purple side here, is equal to XY, which is this entire green side here. And then they give us AY, this side here, which I will mark, is congruent to XB. And I guess to mark these other two sides, I maybe will bracket them so that we can kind of see that they're equal. So in the given, basically what they've done is they've given us two sides. So the question is, can we find a third side? And the answer to that, of course, would be, yes, we can, Mrs. Santa Rosa, because these two triangles overlap each other on YB. So I can use a reflexive property. So I'm going to say YB is equal to BY, and I do flip those letters because of the reflection coming through here to take Y onto B and B onto Y. That is our reflexive property. That is also the third congruency. And so my triangles are congruent by side, side, side. And I have one more, and then we're finished. Given BA is equal to ED, so I'll mark that. Mark that. C is the midpoint of both BE and AD. Okay, so if C is the midpoint of AD, it's going to cut AD into two equal parts. And if C is also the midpoint of BE, it's going to cut BE into two equal parts. And there's our proof, basically. These two triangles are congruent by side, side, side. But pay attention to the proof statement. So in step 2, I'm going to state the congruency that came from the midpoint. So AC is equal to DC, and BC is equal to EC. And that is because midpoint forms two equal segments. And I put them both in the same line because it's the same reason. So put both statements in the same line. Now they gave this B, A, and D, E in the given. I'm done. This is my third congruency. So step 3, triangle ABC is congruent to triangle DEC. And the reason is because of the side, side, side. Side, side, side congruency criteria. And the fourth step and final step is, again, remember that once you have congruent triangles, then all corresponding parts of those congruent triangles are congruent. Well, if you look at angle A and you look at angle D, angle A and D are absolutely corresponding to each other. So I'm going to finish off with angle A is congruent to angle D because corresponding parts of congruent triangles are congruent, also known as CPCTC. Okay, that's it for me. Your homework this evening, or this weekend I should say, would be the corresponding homework that goes with these notes, which would be day 4. Bye. Have a good weekend.